Assalamualaikum and a very good day to Dr. Razif. My name is Hida Alia binti Abdul Ghaffar and I will be presenting the initial part of the lab report for the experiment of T1, equation of state of ideal gases. Our objectives for this experiment are to measure the volume of a column of air as a function of its temperature at a constant pressure. This is following the Gay-Lussac's law. The second objective is to measure the volume of a column of air as a function of its pressure P at a constant temperature T. This is following the Boyle's law. The third objective is to measure the pressure P of a column of air as a function of its temperature at a constant volume. This is following the Amonton's law. And the last objective is to determine the expansion coefficient alpha, the pressure coefficient beta, and the compressibility K of air. Next is the list of apparatus needed for this experiment. The apparatus needed was the gas law apparatus, immersion thermostat, temperature bath, and thermometer. Moving on to the procedures. The procedures were divided into 4 different parts in order to satisfy our objectives. The first part was the water circulating system. We needed to make sure that the water circulating system was working properly before jumping into the other parts of the experiment. Firstly, we filled the thermostat water bath with distilled water until the heating coil was fully immersed. Then we turned the temperature control knob to set it to the initial temperature value, which is the room temperature. After that, we switched on the main power supply and power switch on the thermostat. And lastly, we recorded the thermometer reading when the temperature had stabilized. The second part of the procedure is the measurement of volume as a function of pressure at a constant temperature. Our constant temperature here is 25 degrees Celsius, which is the room temperature. The first step was to remove the top of the mercury reservoir in tube B. Then, tube B was raised or lowered until mercury levels in tubes A and B were both the same. The height L of the air column in tube A and the temperature reading T were recorded. Next, the tube B was raised to a new height, and then the difference in height in between mercury levels in tubes A and B from the scale readings, which is labeled delta H, were recorded. The new height L of the air column in tube A was also recorded. Lastly, the steps 4 and 5 were repeated for 6 pairs of delta H and L, and all these data were recorded in table 1. Moving on to the third part of the procedure. In this part of the procedure, we will focus on the measurement of volume as a function of temperature at a constant pressure, which is 101.32 kilopascal. We set the temperature control knob to the initial temperature of room temperature, which is 25 degrees Celsius. Then, the thermometer reading T was recorded when the temperature had stabilized. After that, we will take the initial air column height in the tube A, which is L, and recorded it in our table. Then, we repeated the steps of 1, 2, 3 for the 6 pairs of T and L, and all these data were also recorded in another table, which is table 2. Moving on to the last part of the procedure, we dealt with the measurement of pressure as a function of temperature at a constant volume. Our constant volume was 26.95 milliliters. To set this part of the procedure up, firstly, we set the air column height L of tube A to a suitable height by varying the position of tube A, and then we recorded the value. Next, when the thermometer reading had stabilized, we took it as the initial temperature T. For the initial pressure, we recorded it by measuring the delta H. Next, we kept the volume of air constant by adjusting the height of tube B. But the temperature T of air was increased using the temperature control knob. Then, when the thermometer reading had stabilized and the new pressure P can be read from the delta H of tube A and tube B, the new temperature T was recorded. Then, steps 4 and 5 were repeated for the 6 pairs of T and delta H. As per the previous procedures, all these data were recorded in Table 3. In this next slide, we have inserted the tables that we have acquired from the data that we have obtained and recorded previously. That is all from me for the initial part of the experiment and the lab report.
Hi, my name is Faznul Muhammad Faris and I'll be presenting the data analysis part. From the result that we get, we have to plot the graph of the pressure versus inverse volume and volume versus temperature and pressure versus temperature. And then we have to calculate the slopes and the y-intercept of the graph. And then from the data obtained, we can calculate the coefficient of alpha, beta and k constant. This is the pressure versus inverse volume graph. As you can see, it's almost straight line there. And this is the volume versus temperature graph. And this is the pressure versus temperature graph. From the graph 1, that is the pressure versus inverse volume, we can calculate the gradient and the y-intercept. That is, the gradient is negative 6345.33 and the y-intercept is 372.95. And for the uncertainty, we calculate using the least square method and we get the value of the gradient is negative 6345.33 plus minus 4714 kPa over milliliter. And the y-intercept is 372.95 plus minus 96.04 kilopascal per milliliter. From the graph 2, that is the volume against temperature, we can calculate the gradient, that is 0.0648, and the y-intercept, that is 25.32. And we use the least square method to find the uncertainty, and we get the gradient is 0.0648 plus minus 0.0047, and the y-intercept is 25.32 plus minus 0.042. And in the graph 3, that is pressure versus temperature, we can calculate the gradient, that is 0.3625, and the y-intercept, that is 95.86. And we use the least square method to find the uncertainty, that is for gradient, we get it 0.3625 plus minus 0.0222, and the y-intercept is 95.86 plus minus 0.959. From the data that we obtain, we can calculate the coefficient of alpha, beta and k. And for the alpha, with the uncertainty, we get 0.0023 plus minus 0.0002. And when compared to the standard volume and when compared to the standard value, we get the percentage of deviation is 31.55%. For the coefficient of beta, we calculate it with the uncertainty, that is 0.0034 plus minus 0.0002. And when compared to the standard value, we get it 7.18% of deviation. For the k, we use the equation 8 in the lab manual, and we get it 0.0063 plus minus 0.0012 kPa. When compared to the standard value, we get it 41.12% of deviation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fatin Nur Aina Atira and I will discuss the next part of this slide report, which is discussion, the precaution, the conclusion, and the reference for this slide report. So as for discussion, from the data we got, the graph pressure against inverse volume, volume against temperature, and pressure against temperature was plotted. For all the graph plotted, we got all three increasing linear graph. From the graph, we found that the expansion coefficient by using the equation of 3a in the lab manual, and the value we got is 0.0023 with deviation of 31.55%, while the value for the pressure coefficient by using equation 3b is 0.0034 with deviation of 7.18%, while the compressibility is 0.0063 with deviation of 41.12%. This shows that the experiment does not obey the ideal gases law, since the law for the ideal gases is that all the gases molecules do not exhibit intermolecular forces between themselves. And as for the precaution we need to take before doing this experiment is we need to make sure that the delta H for part 1 and part 2 remain constant, because the for part 1 and part 2 the delta H is we using the same value, so it will not affect the length in tube A. Secondly, we need to make sure that the reading of the thermometer is accurate when it's remain constant. Last but not least, we need to make sure the position of our eyes is perpendicular to the scale reading of the apparatus to get the exact reading. And as for the conclusion for this experiment, we got that the gradient for the graph pressure against inverse volume is negative 6345.33 ml, while the y-intercept is 372.95 kilopascal. And for the second conclusion, we got from the graph volume against temperature, the gradient is 0.0648, while the y-intercept is 25.32 milliliter. And for the graph pressure against temperature, the gradient is 0.3625, while the y-intercept is 95.86 kilopascal. And from the objective, we answered that the expansion coefficient is 0.0023 degrees Celsius, while the pressure coefficient is 0.0034 degrees Celsius, and the compressibility of air is 0.0063 kilopascal. And lastly, we take reference from the link from the slide. And that's all from us. Thank you.